transaction that writes later determine the value of Q, as I discussed in the previous session. If Tj writes later, the value that Tj writes on Q is the last value of Q. If, on the other hand, if Ti writes Q and be the last operation, the result will be what Ti writes on Q. So the order of these two operations is important. Any of them that writes later determine the last value of Q. So this operation also has conflict. Okay, if two operations do not conflict, the order of them is not important, so we can change the order of this operation without changing the last result. But if the order of operations is important and they have conflict, we cannot change the order of their execution. If we change the order of their execution, the final result will be changed. As we said in the previous session, if we have two operations on different data item, for example, one transaction reads P and the other transaction write Q, these two operations do not conflict because they work on different data item, and these two operations do not affect each other because one works on P and the other works on Q, and the order of execution of these two operations does not matter, and these two operations do not affect on each other. So these two operations do not conflict, and we can change the order of their execution freely and without changing the final result. We can move these operations and change their order of execution. Okay. Now let's continue and define conflict serializability. A concurrent schedule, concurrent schedule, for example, S is conflict is conflict equivalent to a schedule S prime if by changing the order of non-conflicting instruction, if by or swapping non-conflicting instructions of S, it converts to S prime. If we have two a schedule S and a schedule S prime, and we change the order of execution of the instruction of S, the non-conflicting instructions of S. I mean, we only change the order of execution of instruction that do not have conflict. Okay, non-conflicting. We swap or change the order of execution of non-conflict instructions of S, uh, and convert it to S prime. Uh, Let me uh, show it on an example. Uh, okay. Uh, Suppose we have a schedule S3 T1 T2. In a schedule S3, transaction T1 reads A and modify A, then writes A. Here I do not write the computation. For example, uh, computation on A is omitted. Here we read A and, for example, minus $50 from A, and then write A. I omitted the computation. Only we show read and write operation here. Then suppose transaction T2 read A, modify A, and then write A. Then transaction 1 reads B, modify B, for example, adds $50 to B, and then write B. Then transaction 2 reads B and modify B and writes B. Uh, this is a schedule 3. Okay. Um, Here we have some operation read and write. We are going to swap the order of execution of non-conflicting operation. Here operation read A uh, and operation read A in T1 and operation read A in T2 do not have conflict. But operation write A in T1 and operation read A in T1 has conflict. So we cannot change the order of execution of these two operations. Here, write A in T1 is executed first, then read A in T2. T2 is executed later. We cannot change the order of execution of these two operations. We cannot move read A above and write A below. We cannot change the order. But here, read A in T2, also write A in T2 with read B in T1 and write B in T1. These operations do not conflict because they work on different data item. Read and write in T2 here works on A, but in the left side, T1 read and write B. So they work on different uh, data items. So we can change the order of execution of these non-conflicting. We can in these non-conflicting operations we can move these two operations below and down, and we can move these two operations two operations up. So by changing the order of execution of these non-conflicting operation, we get another uh, schedule, a new schedule.
Doctor,
If you
excuse
want,
me, doctor.
yes,
Could
please.
you repeat from
Yes,
beginning, from
yes, of
concurrent schedule, please?
yes. Uh, Suppose you have a concurrent schedule, okay, like a schedule S3. A schedule S3 is a concurrent schedule. If you move and change the order of execution of non-conflict operation, some operations have conflict, some operations do not have conflict. We cannot change the order of execution of conflicting operation. We only can change the order of execution of non-conflicting operations. So here, for example, in schedule 3, we write A in T1 is executed first, then read A in T2 is executed later. We cannot change the order of execution of these. We cannot move read A up and write A down, because these two operations, write A and read A, in T1 and in T2 have conflicts, and we cannot change their order. But read A, write A in T2, and read B and write B in T1. These operations do not have conflict because they work on different data items. So we can change the order of execution. Here, read A, write A are executed first, and then read B and write B. But we can change this order. We can move read B and write B up, and read A and write A down, and the order of execution will be changed. Let me write it here. Read A, write A. Uh, then we moved up, read B and write B. So we have here uh, read B and write B. These two operations are executed first, and then read A and write A. These operations of T2 is executed then, and after that we have read B and write B operations in T2. So as you see, we changed the order of execution of non-conflicting operations. Read A, write A. Do not conflict, read B and write B. So we uh, can change their execution. So by definition, as we said here, a concurrent schedule S is conflict equivalent to a schedule stream if by swapping non-conflicting instructions of S, it converts to S3. Here, by swapping the non-conflicting operations of S3, we convert it to another schedule. Suppose we name it S1. Here, S3 is conflict equivalent to S1, because by swapping, by changing the order of execution of non-conflicting operations, we can convert S3 to S1. So S3 is conflict equivalent to S1. Okay, is it clear, or you need I explain more?
Yes,
Any
please,
question?
doctor, if you can.
Okay, clear, doctor.
Clear? So if we can change the order of execution of non-conflicting operations and convert an schedule to another schedule, we say these schedule are conflict equivalent. Schedule S3 and schedule S1 are conflict equivalent because one of them can be converted to the other one. Okay, so they are conflict equivalent. Okay, as you see, schedule S1 is serial. This is a serial schedule. As you see, four operations or all the operations of T1 are executed first, and then all the operations of transaction 2 are executed. So this schedule is a serial schedule. So schedule S3 is equivalent to a serial schedule S1. Uh, if a schedule is equivalent to a serial schedule, we say that schedule is conflict serializable. Here, schedule S3 is conflict equivalent to a schedule S1, which is serial. So schedule S3 is called conflict serializable. This means that by changing the order of non-conflicting operation, uh, schedule S3 is converted to a serial schedule. So we have another definition.
So, Doctor, what's the difference now between the orders in Schedule 3 and Schedule 1? Here, we write A, read and write A, then we read and write A. So we'll take new values, right? And when we read and write B, it's not affect the another one. Why we did this serializable?
Yes, these two schedules are equivalent. You are right. Uh, in the final result, we have the same result. Okay, the result of these two schedule is the same because only non-conflicting operations are swapped. So they are equivalent. Okay, uh, the final result in both schedules are the same. But why it is important? Because uh, we know that serial schedules are consistent, as we learned in the first session. Okay, serial schedules are consistent. Okay, but concurrent schedules may be consistent or may not be consistent. Okay, but if we have a concurrent schedule which is equivalent to a serial schedule, then that concurrent schedule is also consistent because that concurrent schedule is equivalent to a serial schedule, and we know that serial schedules are consistent. So also that concurrent schedule is consistent. So uh, serializability and conflict equivalent and conflict serializability is important because of this fact. We are going to produce, we are going to produce concurrent schedules that are equivalent to serial schedules because we are going to be consistent. If we produce concurrent schedules that are not equivalent to serial schedules, we cannot guarantee consistency. Uh, because of this fact, uh, equivalency and serializability is important. Here we say that we have, let me write the definition. If if S is conflict uh, equivalent uh, to serial schedule sprint, then we say S is conflict serial serializable. Okay, conflict serializable. An schedule is conflict serializable if that schedule is conflict equivalent to a serial schedule, as you see for S3 and S1. S3 is a conflict equivalent to S1, and S1 is serial. So S3 is conflict equivalent to a serial schedule and is called conflict serializable. This means that S3 can be converted to a serial schedule. When we say that an schedule is conflict serializable, that means that we can convert that schedule to a serial schedule by swapping non-conflicting operation, as you see for S3 and S1. Is there any question? Any question? No?
Thank you, Doctor.
Okay. Let me continue. Okay. So we defined conflict equivalent and conflict serializable here. Uh, okay. Uh, a question which we can ask here is that uh, do we do we do we can do we can convert any concurrent schedule to a serial schedule by swapping non-conflicting operations. I mean that mm, uh, uh, does any concurrent schedule is conflict serializable? Can we convert any concurrent schedule to a serial schedule by swapping non-conflicting operations or not? As you see, for S3, we can convert it to S1. Can we do this conversion for any concurrent schedule? Do you Can you answer the question?
If it's conflict, then we cannot, I think.
Uh, Here
Maybe
we
this way making crossing by informations.
okay. Here we have conflict. Okay, but as you see, we have conflict here also. Read A and write A in T1 have conflict with read A and write A in T2. But on the other hand, read A and write A in T2 do not have conflict with read B and write B, and we can swap non-conflicting operation. So we may have conflict, okay, but also we may swap non-conflicting operations and we get a serial schedule. So existence of conflict is not enough to say that we cannot convert a concurrent schedule to a serial. Uh, uh, we may have schedules that has conflict, but they can convert to serial schedule. As you see for S3, in S3 we have conflict, but we could convert it to a serial schedule. Let me show another example. Suppose we have these schedule T3, T4, T3, read A, T4, write A, and T3, write A. Okay. Here we have a concurrent schedule. Let me call it S7. S7, a concurrent schedule.
Assalamu alaikum, Doctor. Sorry, can you accept a student to log in
Yes.
class? Thank you very much.
Yes. Okay. As you see here, in S7, read A in T3 has conflict with write A in T4. So we cannot swap the order of read A in T3 and write A in T4. Read A in T3 is executed first and then write A in T4. Because these two operations have conflict, we cannot move write A up and read A down because they cannot be swapped because they have conflict. Also, write A in T3 and write A in T4 have conflict, and we cannot swap. These operations. Write A in T4 is executed first, and write A in T3 is executed later. Okay, if you are going to convert these concurrent schedule to a serial schedule, either T3 should be executed first and T4 is executed later, or T4 is executed first and T3 is executed later. So this should be converted to T3, T4. Suppose operation of T4 is executed and then operations of T3. This is one serial schedule. The other serial schedule is this schedule that T3 is executed first and T4 is executed later. Read A, write A, and write A. If schedule S7 is going to be converted to the upper schedule, write A should move up and read A in T3 should move down. But we cannot swap write A in T3 and read A in T3 and write A in T4 here. So we cannot convert S3 to the above schedule, uh, because these write A should be move up, but this that has conflict with read A and cannot move up. If you are going to convert this concurrent schedule to the below schedule in the right side, uh, write operation should be moved down, but uh, this operation has conflict with write operation of T3 and cannot move down. So we cannot convert S3 to any of these serial schedules. So S3 cannot be cannot be converted to a serial schedule by moving non-conflict operation, because um, we cannot move operation of T4 up, and we cannot move operations of T4 down, because uh, operation because write operation of T4 has conflict also with read operation and also with write operation, and write operation of T4 cannot move up and cannot move down, and uh, this operation write operation of T4 has blocked by two operation has blocked by two operations of T3 and cannot move up or cannot move down, and cannot convert it to a serial schedule. So S3 is not conflict serializable. S3 is, excuse me, S7 is not conflict serializable. Uh, okay, any question? So
So the answer, not all time we can conflict it.
yes, some we can convert some concurrent schedule to a serial schedule, and we may not we may not a concurrent schedule may not be converted to any serial schedule, because of conflict, because of the conflicting. Uh, Here, write A has conflict with read A, also has conflict with write A, so it cannot go up and cannot go uh, down, so cannot be converted to a serial. So sometimes we can convert a concurrent schedule to a serial schedule by swapping non-conflicting operations, and we say that a schedule is conflict serializable, and sometimes we cannot convert it, so it is not conflict serializable. Uh, okay, as one of your friend asked me why serializability is important. Serializability is important because if a concurrent schedule uh, be serializable, it is equivalent to a serial operation, and consistency holds, because any serial schedule is consistent, and any concurrent schedule that be equivalent to a serial schedule is also consistent. Because of this fact, serializability is important. So we are going to produce concurrent schedules that are serializable. We have two types of serializability: conflict serializability, as I told you here. The other type is view serializability. Let me define the view serializability. view equivalent and view serializable. Serializable.
Sorry, Doctor. Some of students need login to class. Can you accept, please? I'm apologize for you.
Yes, of course.
Thank you very much.
You are welcome. Okay. Okay. Um, view equivalent. Uh, what is a view equivalent? Uh, uh, schedule S is view equi view equivalent uh, to schedule S prime if uh, three conditions are met. Three conditions are met. Uh, which are these conditions? Condition one, for any data item q, for any data item q, if uh, transaction ti reads the initial. Sorry for the problem of writing. I do not know what's the problem. If transaction ti reads the oh, sorry. Okay. If transaction ti reads the initial value of q in S, then transaction ti must in Spring also read the the initial value of q. What is the initial value? Uh, Suppose we have a schedule, we have transaction Ti, transaction Tj, and we have another schedule, transaction Ti, transaction Tj, for example, a schedule S and a schedule S prime. In a schedule S, suppose Ti reads A, because this operation of read is the first operation, and there is not any write. There is not any write before this operation. So the value that the value that is read is the initial value, original value of Q, because Q uh, has not been written yet. So if we read Q, we read the initial value, and if after that we write Q by Tj, uh, read Q of Ti reads the initial value. But suppose in S prime, first Tj writes Q and then Ti reads Q. Uh, this read Q, this operation read Q does not read the initial value, and it reads the value that has been written by the write operation of Tj. So in S prime, this operation do not read the initial value, but in S, this operation reads the initial value. The first condition says about this issue. Uh, this condition says that for any data item Q, if a transaction Ti reads the initial value of Q in S, then transaction Ti must in S prime also read the initial value of Q. So here S and S prime do not hold uh, this condition. This condition do not hold for S and S prime, because in S um, Ti read the initial value, but in S prime Ti reads does not read the initial value. It reads the value that has been written by Tj. Is it clear?
Could you explain it more, please?
Can you repeat it, Doctor, please?
Yes. Here condition 1 does not hold. Why? Because in schedule S, the value that Ti reads, uh, what's the value that Ti reads? The value that Ti reads is the initial value. Suppose Q, okay, suppose Q has the initial value of 1000. Okay, here if Ti read Q, Ti reads the value of 1000. Okay, but here in S prime, suppose Tj writes Q, then Ti read Q. Uh, suppose the value that Tj writes is 2000. Here Q will be 2000 if Tj writes this value. Okay, um, let me write it here. Q is set 2000. Then when Tj writes Q, the value of Q is 2000, and when Ti reads Q, it reads the 2000, the value that Tj writes on Q. So uh, in the left side, in S, Ti reads the initial value, which is 1000. But in the right side, in S', TI does not read the initial value. It reads the value that has been written by TJ, and it reads 2000. So these two uh, these two schedules are not view equivalent because this condition does not hold for these two schedules. Okay, is it clear?
Thank you, doctor.
Okay. Now let me explain the second condition. Condition 2. Okay, I have problem by this environment. Condition 2. What is the condition 2? Condition 2 says that for each data item Q, if transaction TI executes read Q in S, and if that value was produced by a write Q executed by TJ, then the read Q of TI must in Spring also read the value of Q that was produced by the same write Q operation of transaction TJ that was produced by the
Excuse me, doctor. There is some students they want to attend.
okay. By the same operation, write Q of TJ. What this condition means? Okay, let me give an example. Suppose we have 3 transaction TI, TJ, TK. Okay, TK, for example, write Q, TJ, write Q, and TI read Q. This schedule is S. In the right side, suppose we have another schedule with these three transactions, ti, tj, tk, tj write q, tk writes q, and ti reads q. Okay, let this be schedule S3. Okay, in schedule S, ti reads the value of q. The value that ti reads was produced by what transaction? By tj or tk? What value ti reads?
Read TJ.
Yes, the value that tj writes is read by ti. But in the right side, what value is read by
TK.
ti? Yes, tk, because
It's the
first
latest one.
tj writes and then tk writes and overwrite the value of tj, and the last value is written by tj. So when ti reads the value of tk, but in the right side, uh, ti reads the value of tj. So these two schedules, uh, for these two schedules, this condition does not hold. Um, if this condition if this condition holds when in both schedules ti reads from the same operation, from the same write operation. Here in schedule S, read q of ti reads the value was produced by the write operation of tj, but in the right side in S prime, the value that ti reads is the value that was produced by the write operation of tk. So the condition does not hold. Condition 2 does not hold here. Okay, is it clear? Any question?
Doctor, why does not hold here? Can you repeat this?
Why it does not hold? Because see the schedule S, okay, in the left side. Suppose tk write value, for example, 1000, and tj writes the value uh, of q, which is 2000. Okay, the value that ti reads in schedule S is 2000. But in the right side, suppose tj also again write 2000 on q, and tk write the value of 1000. Because the last one that writes on q is tk, the value of q will be 1000 at last. Okay, so when ti goes and reads q, it sees the value of q is 1000. So in the right side, the value that q reads is 1000. In the left side, the value that q, the value of q that ti reads is 2000. So they are not the same. So the condition does not hold. Uh, the condition holds when in both schedules the value that transaction read be the same, or uh, a read operation of a transaction read the value was produced by the same operation. In the schedule S, ti reads the value of q, which was produced by the write operation of tj. But in Spring, Ti reads the value of Q that was produced by write Q of Tk. Uh, so uh, this condition does not hold because the condition says that in both schedules the value of Q that is read must be the same, or both read operation in both schedules should read from the same write operation. But here we do not have this condition, so this condition does not hold. Okay.
Okay, clear, doctor.
Okay. Uh, Let me continue and say the third condition. Third condition, condition 3. The condition 3 says that for each uh, data item Q, data item Q, uh, the transaction, the transaction, uh, the transaction, if any, like if any, if it was existed, if it if it it has any transaction, if any, that perform performs the final write Q, write Q uh, in S must perform the final write Q in a Spring. The final write Q in a Spring. This condition says that if there is a transaction in a schedule S that writes the final write on Q in a schedule S prime, also that transaction should write uh, the final value on Q. Let me explain by an example. Uh, Suppose here we have two transactions Ti and Tj. Here, suppose Ti write Q and then Tj write Q in S. But in S prime, Ti, Tj. Suppose first Tj writes Q and then Ti writes Q in S prime. Okay. In schedule S, the final write is done by Tj, but in a schedule S prime, the final write is executed by Ti. So these two schedule uh, for these two schedule, this condition does not hold, and these two schedules cannot be uh, cannot be equivalent because this condition does not hold for them. This condition says that if a transaction writes the final value on Q in one schedule, in the other schedule also that transaction should write the final value on Q. In schedule S, TJ writes the final value on Q and executes the final write. But in schedule S prime, TI writes the final, executes the final write. So they are not the same. So condition 3 does not hold here. Does not hold here. Any question?
Doctor, so when the value of Q 100, what is the value of the TJQ?
Yes. Suppose the value that Ti writes is 100. The value Tj writes is 200. Okay. Okay. In S, the value which is written on Q is 200 because TJ writes the final value on Q. So the final value of Q in S is 200. But in the right side in S prime, Ti writes the final value and Q, and the final value of Q is 100. So as you see, these two schedules uh, are not equivalent. The result is not the same. So this condition does not hold. This condition holds when in both schedules one transaction executes the final write. In the left side in S, Tj executes the final write. But in the right side in S prime, Ti executes the final write. So they are not the same. So condition does not hold here. Okay? Is it clear?
Okay, doctor, but we say when the TI in schedule S dash 200 are the same, the final at the schedule S 200 here and 200 here, that's don't condition the same
No,
value.
no. Uh, this condition talks about the last write. Okay, even the value is the same. For example, suppose Ti writes 200, okay, and Tj 200. Uh, Again, these two schedules are not equivalent because the value is the same, but in the left side, the final write is written by Tj, and in the right side, the final write is written by Ti. Again, these two conditions are not equivalent. So, what is important is which transaction uh, does the final write. The final write in the left side is done by Tj. The final write in the right side is done by Ti. So these two schedules are not equivalent, are not view equivalent. I mean that the value itself is not important, but what is important is which transaction does the final write. Okay,
Okay, okay, doctor. Okay.
so
Okay, doctor.
the value may be the same, but again they are not equivalent because the final write is written on Q by different transactions in these schedules. Okay, mm, so these three conditions are the conditions of view equivalent. We say that two schedule S and S prime are view equivalent if condition 1, condition 2, and condition 3 hold for them. Okay, let me review. In condition 1, we say that if a transaction in one schedule reads the initial value in the other schedule, also that transaction should read the initial value. As you see in S here, Ti reads the initial value, but in S prime, Ti does not read the initial value. So the condition 1 does not. Condition 2 talks about which reads from which write. If a read operation reads from a write operation, that should be the same in both schedule. I mean that if transaction I reads from operation write of TJ, in the other schedule also that read operation should read from the same write operation, not from another operation. Okay. Uh, this read operations should read from the same write operation in both schedules. In the left side, read Q of Ti reads from write operation of Tj, but in the right side from Tk, so they are not equivalent. And the third condition talks about the final writes. In both schedules, the final writes should be same. I mean that if a transaction does the final write in one schedule, that transaction also does the final write on the other schedule. If for any data item these three conditions are held for two schedule S and S prime, then we say that S and S prime are view equivalent. Okay, as I wrote it here, a schedule S is view equivalent to a schedule S prime if three conditions are met. Okay. Now let's define a view serializability or view serializable. Okay. S is view serializable if it is view equivalent to a serial schedule. If an schedule is view equivalent to a serial schedule, then we say that a schedule is view serializable. This means that that schedule is view equivalent to a serial schedule. This is defined similar to conflict serializable. In conflict serializable, we said that an schedule is conflict serializable if it is conflict equivalent to a serial schedule. Here we say that an schedule is view serializable if it is a view equivalent to a serial schedule. Okay. let me give you an example. Consider this schedule. Schedule 9. T3, T4, and T6. T3, read Q. T4, write Q. T3, write Q, and T6, write Q. Okay. Let me call this schedule S9 schedule. Let me ask you a question. Is this schedule conflict serializable? Can we convert it to a serial schedule by swapping non-conflicting operations? Is this schedule is conflict serializable?
No, it isn't.
Why?
Because here we have write Q. If we write
Okay.
Q in T4, then the
Yes.
T3 it will take T4 values.
Yes.
So
Yes.
if we change it, it will be change all the values.
Here, if we are going to convert it to a serial schedule, T3 and T4, for T3 and T4, we should convert this schedule to a schedule, to a serial schedule, which first T3 runs and after T4, or first T4 should be run and then T3. But here, this operation, this write operation, it cannot move up and cannot move down, because this operation has conflict with read queue and write queue of T3. So we cannot move write queue of T4 up or down. So T3 and T4 cannot be serial with respect to each other. So this schedule cannot be converted to a serial schedule. So this schedule is not conflict serializable. S9 is not conflict serializable, because write Q of T4 is blocked by read Q and write Q of T3. Okay, what about view serializability? Is S9 view serializable? If S9 is view serializable if three conditions of view serializability hold for S9 and a serial schedule. Consider serial schedule T3, T4, and T6. I mean that first T3 is run, then T4 is run, and then T6 is run. This is the serial schedule: T3, T4, T6. Uh, let me check the view equivalency of this serial schedule and S9. Okay. Uh, let me check
It is
if
it's not
it,
serial schedule.
uh, S9 is not serial. Okay, but is S9 view serializable? Three conditions should be held for uh, S9 and a serial schedule. Let me
But
check the
in
three
this case
conditions
also it will
for
be not the
the
first
first.
condition.
What is the first condition? The first condition
The
talks
first
about initial
condition,
value. Okay,
T3.
yeah,
T3.
if we read
initial
the
value in
initial
S9.
value,
Which trans? Let me explain. In S9, which transaction reads the initial value?
T3.
T3,
T3.
okay? T3. T3 reads the initial value of Q because no writes is done before read Q of T3. So T3 reads the initial value. In this serial schedule, T3, T4, T6, uh, does T3 reads the initial value in
No.
serial schedule? Yes, because T3 is
Why?
run first. Let me write the complete
Compare. Mm.
serial schedule: T3, T4, T6. Okay, T3 read Q, then write Q. Okay, then T4 write Q, then T6 write Q. Okay, in this schedule, this is a serial. Okay, serial schedule. This
Serial.
schedule, which transaction reads the initial value of Q? Again, T3, because before read Q of T3, no writes, no write uh, is done. So T3 reads the initial value of Q. Okay, so the first condition holds for both schedules. The first condition holds for S9 and for this serial schedule. Is it clear?
Yes, doctor. Thank you.
The first condition talks about the initial value. The condition says that if in one schedule transaction I reads the initial value of Q, then in the second schedule also transaction I should read the initial value. Here T3 reads the initial value of Q in S9 schedule. In serial schedule T3, T4, T6, T3 reads the initial value. So in both schedule T3 reads the initial value. So condition 1 holds. Condition 1 holds because in both schedule T3 reads the initial value of Q. Okay, let's check the second condition. The second condition says that if a read operation reads the value that was produced by a write operation. In the second schedule also, that read operation should read from that write operation. Uh, Condition 2 talks about which read operation reads from which write operation. Here in S9, only T3 executes a read operation. And this read operation reads the initial value and does not read from a write. So in S3, no read operation reads from no write operation. Also in serial schedule, um, we have only one read operation here in T3. This read does not read from any write. So the condition is same in both schedules. In schedule 9, no read operation reads from a write operation, and in serial schedule also no read operation reads from a write operation. So condition 2 also holds. Uh, and
Could you explain that, please, Doctor?
explain
Again?
again.
Yes,
Okay,
please.
let me go to condition 2. Condition 2 talks about which read operation uh, reads the value of what write operation. Okay, here in S, read Q of Ti reads the value that was produced by the write of Tj. In S prime, read Q of Ti reads the value was produced by write Q of Tk. So condition 2 talks about which read reads from which write. Okay, if a read operation reads from a write operation in one schedule, in the other schedule also that read operation should read from the same write. Okay, but here in our example, here, sorry, uh, it moves very more. Okay, here, uh, please stop. Okay. Okay, here we have only one read operation, read Q in T3. This read operation does not read from a write. Okay, so there is no read that reads from a write in S9. Also in serial schedule, the only read operation is read Q of T3, and this read Q reads the initial value and does not read from write. So in both schedule, we do not have a read operation that that reads from write operation. So condition holds. If we had a read operation that reads from write operation, and in the other schedule there was a read that reads from a different write, then the condition does not hold. But here we do not have a read operation that reads from a write operation, so automatically the condition holds. We do not have we do not have um, I don't find the word. We do not have two read and write operation that condition does not hold for them. Okay, so the condition 2 holds. Condition 2 holds because because there is no read operation that reads from a write operation. Uh, if we had a read operation that reads from the write operation in one schedule, in the other schedule also, that read and that write should be read from each other. But we do not have a read that reads from a write here. So condition 2 holds. What about condition 3? Condition 3 talks about the last write. Which is the last write in S9?
T6.
The last write on Q is done by which transaction in S9? Do you hear me?
T6 the last right.
What is the last write?
T6. Both
Yes, the write
both tables.
of yes, the write of T6 in S9. T6 writes the last write on Q. Okay. In what is the last write in serial schedule? In serial schedule
Same.
also,
T6.
yeah, the same. In the serial schedule also, T6 do T6 does the last write operation on Q. Okay. Uh, so the last write in both schedule is the same and is done by transaction T6. So condition holds, or condition 3 also holds. Condition 3 holds uh, because because in both schedules T6 uh,
T3.
in both schedule T6 uh, does the last write. So S9 is view
You serializable.
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 S9 is view serializable. Why?
Because
Because S9 is view equivalent to a serial schedule. S9 is a view equivalent to a serial schedule of T3, T4, and T6. So S9 is view serializable. View serializability means that a concurrent schedule is equivalent to a serial schedule in view definition, by view definition. Conflict serializable is equivalent to a serial by conflict definition. We have two definitions for serializability: conflict serializability and view serializability. A concurrent schedule may be equivalent to a serial schedule by conflict equivalency or by view equivalency. Here, S9 is not equivalent to a serial schedule by conflict equivalency because T4, the write operation of T4 is blocked by two operations of T3. So S9 is not conflict equivalent to a serial schedule. But S9 is view equivalent to this serial schedule. So the effect of S9 on database is the same as the effect of this serial schedule. And because any serial schedule is consistent, so S9 is consistent. Okay, so we define serializability to guarantee consistency. A concurrent schedule may be a conflict equivalent to a serial schedule or maybe view equivalent to a serial schedule. If we have view serializability or we have conflict serializability, we can ensure consistency. We can sure about consistency of the schedule. Okay. the session is finished at this time. If there is any question, please ask. Any question?
Thank you, Doctor, very much.
Okay.
Thank you, Doctor. Not at all.
Okay. Have a nice night. I see you, inshallah, on
Thank you, Doctor.
Saturday at the university
Of God willing.
in person.
Thank you.
Inshallah.
Goodbye.
Inshallah.
Inshallah.
Thank you, Doctor.
Good night, guys.
Thank you, Doctor.